Hello, I'm going to provide you some clarification on the quiz that we had last week. So quickly, we had 10 questions, but I'm going to only cover 8 because the 2 are just for fun. Yeah. So the first one is about which of the following is not a peripheral modification for morphine. And if you actually had a look at the names of all these, yeah, heroin, quaternary codeine, these are peripheral modification. Yeah, the only thing that's different from here is itopine, which is the ring modification. Okay, and then the second one, yeah, if you have a look at the bracket Cassie again, yeah, the thing that you have to know that if I just click on this particular, so make sure that you know that A is hydrophobic, B is ionic at the back of the receptor, C is van der Waals. So C is the van der Waals, and lastly D is hydrogen bonding. And make sure you know the functionality that binds to this site of the binding sites on this bracket Cassie analgesic model of opioid receptors. Yeah. Which of the following two are problems associated with precursors of aspirin? So this one you need to know. Yeah, there are some close ones. Yeah, for example, I think from here you can see that you chosen mostly corrosive and consistently inconsistent therapeutic responses. But I think a lot of people actually a bit confused is this the stomach upset. Stomach upset, I think, if you think about it, is still a persistent problem in even aspirin, the current drug. Yeah, people still having, you actually ask patients to take aspirin after meals. So it is still a problem. It is not really associated with the precursors of aspirin. What are the problems we want to solve for the derivatives leading to aspirin? Yeah, and then the third one I think is pretty much right or wrong answer. So you need to know. So the answer is acetylates. Yeah, the fifth one, I think this is what caught a lot of people here. Yeah, a lot of people actually not sure whether it's actually the oxidation state of sulfur. So let's have a look at the different oxidation state of sulfur. I've made a very little graphic list of all the ones that listed in the answers. Yeah. So the first two, yeah, which is sulfones and sulfonamides, are the one that will actually give a good binding to the COX-2 receptors. Yeah, and these two are needed. The two oxygen are needed in this case. Yeah, whereas in sulfoxide and sulfide, you see in sulfoxide there's only one oxygen. In sulfide there's none at all. So that tells you that the oxygen moiety is important in the interaction of this terminal end of the COX-2 inhibitor to the COX-2 receptors. Moving on to the last two questions. So, which of the following two spatial arrangements of COX-2 inhibitors lead to good activity? Good activity for COX-2 inhibitors, the first thing you have to know is the arrangement of all the important functionalities should be in a triangle. The first thing you have to know. So in this case, yeah, the further away it is from the triangle is when it's opening up. Yeah, then the triangle framework is opening up. Then the binding interaction is much less because now the different end of these two are away from the binding interactions. Yeah, and the last one, but phenytoin, yeah. So phenytoin undergoes hydroxylation during its metabolic transformation, and then the glucuronidation and so on will come a bit later. So that's it on clarification of quizzes that we had last week. See you in class.